Because we have here cube roots, so first I will rewrite this function to power form. So we have g of t is equal, in parentheses we will have 1 plus tangent of t to power 1/3. Now, to find the derivative of this function, we will use the derivative of function raised to a power formula first. So, let me remind you, when we have x to power n, this is equal, we take down the power, so it's n times x to power n minus 1. So first we will use this formula, and next, because we have composite function here, we have to find the derivative of expression which is inside parentheses. So let's start from the beginning. We have g prime of t is equal. First, we use this formula, we take down this power, so it will be 1/3 times, we copy this whole expression in parentheses, so it's 1 plus tangent of t, and we have the power 1/3 minus 1 times, we have to find the derivative of expression which is inside parentheses. So derivative of 1 is 0 plus derivative of tangent is secant square, so we have square of t. So this is equal, we have 1/3 times 1 plus tangent of t to power 1/3 minus 1 is negative 2/3 times 0 plus secant square is secant square of t. We can change this negative power to positive, so it means this whole expression we have to put to denominator. So in numerator we will have secant square of t, and in the numerator will be 3 times 1 plus tangent of t to power, we have now 2/3, and because we have 2/3 we can rewrite this. Let me copy numerator first, will be secant square of t, 3 times 1 plus tangent t to power, we can put first 2 and everything to power 1/3, because 2 times 1/3 is 2/3. It doesn't change anything when I take first 1 plus tangent t to power 2 and next to power 1/3. Now, when we have power 1/3, we have to take cube root of this whole expression. So numerator we just copy, we have secant square of t over 3 times cube root of 1 plus tangent of t to second power. This is my solution.